Okay guys, welcome back to Java Video Tutorials. This is lesson 11. It also happens to be our first lesson in object-oriented programming. And so from now on, we're just going to be dealing with objects most of the time, and that's really going to help us write more complex programs. So everything we've done before now is has just been the linear programming that was popular about 40 years ago. So let's go ahead and open up Dr. Java and object-oriented programming. It's cool stuff, and even if you already know it, I'm going to get real in depth here, and you're going to learn a lot of intricacies about object-oriented programming, especially with the Java language. So I'm putting this in your here window. There you go. So, first thing we need is an example or some kind of application that we're going to create. And since I really suck at coming up with examples, I am going to code a shape object for you. But first, before we even start typing, I'm going to talk about what is an object and how do you create them, what is an object made of, and what can it do for us. So in Java and your other OOP languages, all objects are created from a class. And a class is basically a definition of how an object should behave or act. And so an object in Java is basically, when you come down to it, you're creating your own data type. So you already know some of the Java data types. You have your integers and your doubles and your strings and your booleans, and they all represent data in a different kind of way. So if we can create our own data types, then really the sky is the limit with our programming, and we can do so much with it. So let's say I'm building an application, and maybe I'm building like a drawing application, so like Microsoft Paint or something. And so I'm going to create an object or a class called shape. And I will be able to use this class to create many shape objects. And every shape object will be able to relate to another shape object. So we start out a class the same way you're used to. I'm just going to say public class shape. Make sure you capitalize that S in shape. But here, instead of saying public static void main, you see we're not writing the starting point of our program. We're supplementing our program by creating this data type. So we're not going to have a main method here, but instead we need to create our class for shape. So usually the first thing you'll see is your field variables or your instance variables, and basically these are the properties of your data type. So in our case, we're creating a shape data type. And if you think about it, shapes can have a certain number of properties. So for instance, you can have the property, is it closed? So like a line would not be a closed shape, but on the other hand, a circle would be an example of a closed shape. So closed, yes or no, that's a Boolean type or a Boolean variable. And you might have some other kind of representation of size, and maybe let's say it has a color. So if we're doing this, or we're like building a Microsoft Paint application or whatever, and we're going to create this shape data type, and it's going to have a color. So I'm going to give it a Boolean closed, and that's just going to be like that. I'm not going to give it a value because different shapes I create are going to have different values of closed. And I'm also going to give it a int size, and I'm going to give it an int red and a green and a blue. So these are basically just your RGB values for the color of my shape. So the shape that I'm creating, my special shape, has these 5 properties, and it can't have any more or any less unless I define them right here. So the next part of our class is called the constructor. The constructor is basically a method that is going to allow you to use this class to create an object. So if I want to create a shape object, I'm going to call the shape constructor. The constructor is going to build this object for me. And it's also pretty simple syntax here. I'm just going to say public because you want all classes to be able to create your shape. So I'm going to say public and then shape. Shape has to be the same name as the class here. So that's why I use shape. Shape is also the name of the method. So it will look like this. That's the shape constructor. That's how it looks. You'll notice I don't have a return type here because when I create a shape object, I'm not really returning anything. I'm creating this object. So inside of shape, I need to give it, I need to be able. Okay, I think the audio just went out. I hope it wasn't out for too long. But when I'm creating a shape, I want to be able to give it these 5 parameters, and I should be able to specify whatever I want for these 5 parameters. So when I create a shape, I'm going to pass in 5 variables. I'm going to pass in a Boolean, and I'm going to call it B. And then I'm going to pass in an int S, int R, int G, and int B. So usually when I create my constructors, I use the same data type of here's the field variables, and then I use the first letter or the first couple of letters in the name of the variable. So I have my braces, and then here I just need to set these field variables equal to whatever was passed into this shape constructor. So let's go ahead and say closed equals C, and then S equals size equals S. That's a very important thing. You have to have the field variable first. You have to say size equals S and not S equals size. The reason for that is this equal sign is not necessarily equals. It's better is assign the value of. So size, which is this variable, is assign the value of S, which is whatever was passed in to my constructor. If I set it the other way around, size wouldn't get changed and we'd have an error. So I'm going to say red equals R, and green equals G, and blue equals B. So now we have our constructor. That was fairly simple to do, and we will be able to call this constructor and create our own shape object. So I'm going to stop right there and go ahead and compile this shape, and do right here, and I'm going to overwrite shape since this is the second time I've done this lesson. And I have an error here. What did I do? Line 9, it says B is already defined. Oh, I have, should be Boolean C, not B. So let's go ahead and compile that again. And now it says compilation completed. Now since I don't have a main method, I can't run my program. But Dr. Java and its fancy interactions window has compiled this this class here, so I'll be able to use it in the interactions window. So let's create a new shape. Well, remember I said we created our own data types. So if we wanted to create a new integer, we'd say something like int x equals 59 or something like that. And that would be a legal statement. But if we want to create a new shape, we're not using the int data type, we're using shape. So shape, and we'll call it s, equals, and then here's a little bit different syntax. We're going to use the keyword new, and then we're going to say what kind of object we want. So shape s equals new shape. And this shape right here is actually the same as this constructor right here. So it's going to take in these 5 parameters. So let's go ahead and fill those in. I'm going to say true, so it is closed, and let's give it an arbitrary size of 35, and pretend it's like a red shape. So it's going to have 255, 0, and 0. So this is going to create our new shape object. So if, what this does, this is kind of a tricky subject that we'll definitely get into more detail later, but S is not assigned the value of this new shape object. And this is one of the little nuances of Java. Can you hear me? I don't know how long I cut out. If it was longer than necessary, then I guess I'll do this lesson again. Otherwise, I'll just leave it. I apologize for that. I will start back to here though, where I say shape S equals new shape. So S is not actually assigned the value of this new shape object. And this is one of the nuances of Java that might be different from a different programming languages. But what happens here is S gets assigned the memory location of this shape object. And S is called a pointer, or that memory location is called a pointer, because the actual shape object is existing somewhere in the Java heap space. And we don't know exactly where that is, but this pointer points to that memory location. So shape S equals new shape. Really, new shape is going out somewhere we don't really know or care, and then S is going to be pointing to that location. Whereas if I just say int x equals 59, well, x is assigned the value of 59, and it goes right there, and it's not pointing to an alternate location. So we'll definitely get into more detail about pointers later on. But I just want to show you here, I can say system.out.println s. Okay, so what do you think is going to happen? I'm saying print line and s. S is this shape object. Well, we know how to print out integers, and we know how to print out Boolean values, and we know how to print out strings. But how exactly are we going to print out this shape object? I mean, we haven't really told it what it looks like as a text version. So if I say this, it's going to return this weird string, shape at C28CB7. And this is some kind of weird memory location, and this will never be useful to you in writing an actual program. The reason this happens, we'll get into in another lesson or two. But the point is, you can't just print out an object. But one thing I can do is I can say print out s dot closed. And s dot closed is going to find the Boolean variable closed in this shape object. This dot here is called the dereference operator. And what it does is it takes the pointer of s, it goes and finds that memory location that for the object that it's pointing to, and it goes and goes to that object, and it takes the closed variable, which is right here. So if I print that out, you'll see that it's true, because when I created my shape object, I gave it true. So I can go ahead and print out any of the variables like s.red 255 s dot blue 0. So you'll see that that's all great, and now I have my wonderful shape object. So in fact, I think I'm going to leave it there for this lesson, and in the next lesson I will I'll add to this class here, and I will also incorporate it into another class that actually has a main method. But for now, I think that was good, and my voice is getting kind of raspy now. So I think it's a good place to stop, and also we're not running too long. 15 minutes and 45 seconds sounds good to me. So I'll see you guys later, and have a great day.